Right, we're going to look at quadratic inequalities, which is going to be a grade 8, possibly 9 level on the higher course. Okay, as we did with quadratic sequences, the general expression for a quadratic is ax squared plus 3x plus c. Some of the things you should need to know is if this number here, a, which we have called the coefficient of x squared, is bigger than 0, in other words positive, you get the U-shaped graph that way around with a line of symmetry down the middle. If which is less than 0, then it's the reverse way around, the sort of M look with a line of symmetry down the middle again. So that's the important part of the sketching. Now, to sketch quadratic inequalities, the first thing you need to do is this. So if I just bullet point various things here, first of all you need to write it as a function of x, either less than 0 or less than or equal to 0 or whatever the symbol is there. You need to get it to 0. Okay? Then what you need to do is to factorize your function of x. Okay? So let me put an example here as I'm actually doing this. So as I'm talking about the notes, it's probably a good idea to do an example. Let's say I've got x squared greater than 4. As I've said on that first bullet point there, you take off the 4 from both sides and you get it as one function of x greater than 0. Now the function of x in this particular, as I've written the expression out here, is another way of writing y bigger than 0, and that's the key to the sketch of the graph where I'll get the values of x to solve that particular quadratic. Okay? Obviously, y is equal to x squared minus 4, because you put a value of x in, square it and take off 4, you're going to get a value for y, which is going to give you coordinates for the graph to draw the quadratic, although I'm going to actually sketch it. So that's the key to the question there. Now if I proceed with this question, the next thing I've got to do is, if you take the graph I'm going to sketch, which is x squared minus 4, okay, I need to find what we call the y-intercept. So y-intercept, which, if I go over to this side of the board here, I'm just going to start to draw my axes out. That's the x-axis, that's the origin, and that's the y-axis. Now, the key to this is, if you want the y-intercept, that's the crossing on the y-axis. Now if you think about it, down the y-axis you've got above the x-axis you've got positive values for y, below the x-axis you've got negative values for y. So therefore x is not moving across or down, so x is equal to 0. Okay? It's often a common misconception that the y-intercept's always the end number, which it is for the graphs we usually use in the GCSE, but for high level you've got to be careful of that. So it is the value of y when x equals 0. So when I put 0 into that, I get 0 squared minus 4, that leaves me with minus 4. So that as a coordinate would be 0 minus 4, the value of y-intercept when x equals 0. So I can plot that on my graph there, which is minus 4. Okay? Now, the next bit, if I can rub that bit out, okay, because I've already talked about that, so I've got just a little bit of room here, what I've said. Okay, move that there. I'll leave my graph where it is there. Okay, so we've now got the the y-intercept, and we're going to get something called the x-intercept. Okay, now you think about that, so I think I've used the word x-intercept as another word for roots. I call these the critical values. It's an A-level word I use a lot because it's it's actually, these values are going to feature in the answer. Okay, so obviously if you go along here, which is the x-intercept, you can see along here that you've got a positive value for x, the origin's there, so x is 0, and the negative values of x. Yeah, so y is not up or, there's no movement in the y going up or down, so y equals 0. Okay, while I'm on the graph at the moment, the key to the sketching, which I'll get to at the end, is if you go any point above the x-axis, and I put little dots there where it's there, you can see as I'm watching these points here, I'm actually physically putting the points there, you can see that y is always positive, i.e. bigger than 0. If you go below the x-axis, like here, there, you can see that y is less than 0, you're getting negative values, and that's the important part to the actual sketching. So, if I go to the x-intercepts, the graph I was sketching was y equals x squared minus 4. So obviously I set y equal to 0 into that. Now, to To do this is a simple one. You should recognise that as the difference of two squares, a special type of factorising, which is x plus 2 and x minus 2. And when that is a key area of solving a quadratic, that could be naught, so the product of two things could be naught. The first part of the product could be naught, or the second part of the product could be naught. So if you set that equal to naught, take 2 off both sides, you get x equals minus 2. Same for the other one, if you set that equal to naught, rearrange it, you'll get x equals 2. That's giving you 2 more coordinates now. When x is minus 2, y is naught. And here, when x is 2, y is naught. Hence the x-intercept where y is naught. And I can pop that back on the graph here. So x equals 2 here, and x equals minus 2 here. You can see by me plotting why the y-intercept, even though it's not going to feature in the answer, it's going to help with the shape of the graph. Now, I already said earlier, okay, that I'll just rub that bit off here, come a bit further down here. I said that if you've got the graph of y equals x squared minus 4, I did something at the start of this talk. I said it's ax squared plus bx plus c. If I said the number in front of it there is bigger than naught, which is there, you can see the a value there is 1, then you're going to get the classic U-shaped graph of a line of symmetry down the middle. Okay, my points obviously give that, so if I go back here and sketch it, you've got a perfectly symmetrical graph with the y-axis being a line of symmetry. It's a sketch, so it's not perfect from that. Okay, obviously that's a rather simple graph, so for more complex ones we move on. I may do another presentation on that, then we'll see why this is all important for that. Okay, the final stage for this graph, I tend to, you've all got red pens, so I'm going to put a red pen on that. I'm just going to rub all this out here. Now, going back to the key part now, I've got my graph sketched, and remember my question was x squared bigger than 4, that's what was given. The question would be phrased as find the values of x where that's true. Take 4 off both sides, you saw me do that earlier. And that is the function of x, which is really y. So I'm trying to search my graph, on my graph, where the values of x, which solve the question there, where y is bigger than 0. Now, if I get my red pen out here, okay, you can see I'm going to shade anything got, I'm going to go, anything got on this curve, I'm going to put in red if it fits where y is bigger than 0. Well, obviously, y is bigger than 0 above the x-axis, so I can go in red here, and I'll keep going in red all the way down here. Now, obviously, when I get to the x-axis, y is equal to 0. It's not bigger than 0, so I'm actually including that. And we know from our talks we've had before, we have an open circle, and that means it's not included. If I go further below here, y is less than 0, which doesn't fit what I want there. And obviously, when I get back to around the curve to here, y is equal to 0. I'm actually including that. But anywhere beyond that, I'm including. So it's the red part of the graph, which is going to give me the point where y is bigger than 0. But remember the question was, solve that for x squared minus 4, i.e. I need to find the appropriate values of x. Now, I'll do it the other way around. If I can imagine me translating that x-axis up here and drawing it like that, there's the origin, which is in line with that. There's the critical value, or x-intercept 2. There's the critical value minus 2. Now, obviously, my values of x are going to go beyond 2, because x equals 2, y is 0, and I want it to be bigger than 0, so you need to move that way. Any value of x that way, you're going to give you a value bigger than, a value of y bigger than 0. So you're not including the 2, because y is 0 there. Anywhere that way, x is going to be bigger than 2. The other side of it here is this point, another critical value called the root, or x-intercept, x is equal to minus 2. That's obviously giving you y to be 0, which you don't want. Okay, so you put a circle on that and you move that way. There's always a key to the question that when I look at the answers now, x is bigger than 2, or, this is my solutions, or x is less than minus 2. Okay, because there was no equals on that, that means there's no equals on the actual answer for that one. Okay, and that really concludes the answers to that. I'll just do one more example, which when I did this with the group previously, I'll just do one more example, but I'll do a bit quicker on this one. Let's say we've got the example 3x squared, and I'll try and get the inequality less than or equal to 27. Right, before rearranging it, you can see there's a multiple of 3 throughout everything, so I'm going to divide that by 3. Let me just rub that out here, because that's not part of the question now. So you divide it by 3, x squared is less than or equal to 9. Take 9 off both sides to get it as with the with the 0 on the right hand side, so that's x squared minus 9 is less than or equal to 0. There's your function of x, which is really y. So you want to find the values of x where y is less than or equal to 0. That's the key to the shading, the red on the graph, okay? Okay, like I did before, much quicker now. I've got y equals x squared minus 9. I want the x, so the y-intercept, which is the value. Let me get the graph drawn here again. There's the x-axis, there's the y-axis. There's y equals 0, which is along the x-axis. There's y bigger than 0, which is above the x-axis, and where's y, which is going to help me get the right places on that. Y-intercept, well, obviously down the y-intercept as the origin. Y-intercept is the values of y when x equals 0, so I put a 0 into that, which yes, it is the end number, which is 0 squared minus 9, which gives you minus 9, so it goes through the point 0 minus 9. Let's plot that roughly, there it is. Okay, alright, I'm just going to put this above the graph here, y less than or equal to 0, because that's the key for me solving this. Okay, just rub this bit out here again. Also, we need the x-intercept, which I called previously on the previous example, roots or critical values. So you've got y equals x squared minus 9, which is the graph I was sketching there. Just check that's right, yes it is. And to set, obviously you want the x-intercept, so you put y equals 0 because along here y is 0, so you set that equal to 0. Okay, and you factorise that into two brackets called the difference of two squares, x plus 3, x minus 3. Set them equal to 0, that and that equal to 0, and you get x equals 3 and x equals minus 3, which means it goes through 3 0 and minus 3 0. The values of x-intercept when y equals 0, plot them on here. And for these rather simple questions, because we need to get the understanding behind this quadratic inequalities, we're doing simple examples. A plot of those on there. Because the number in front of the x squared, again, the a bit is 1, which is positive, bigger than 0, it's the u shape. I can sketch this here, go around here, like that, and you've got that there. Just one important point there. Another way you could have solved this here, okay? I'll just go over here. You could have done it this way. Now, obviously, the more complex the quadratic gets, the harder it is to do that. But if you add 9 to both sides, do it a different way to complete the square, that. You take the square root, remember when you square root, you have a plus or minus the square root of 9, which gives you plus or minus 3, and that gives me exactly what I've got there, but in a different way, but that's only a simple case. Again, the red pen comes out. The key was to find this time where y is less than or equal to 0. Well, obviously here, y is bigger than 0, so that's not going to go red. Going down, and obviously when I hit this point here, y is equal to 0, so it's included in the equals bit there, so you do a shaded circle, and obviously anywhere down here, y is less than 0, so I go along my graph in the red pen all the way round to there, and when I get back round there, y is equal to 0, which I want. Anything above it is y bigger than 0. And there is my answers from there. And finally, from there, I'll just rub this bit out here. I'll draw my x-axis this time underneath, like that. There's the origin, there's the critical value of root 3, there's the critical value of root minus 3. As you run from there, you're including the minus 3, and that was always evident from the question anyway, because the question had an equals in it at the start, and we're including the 3, because at x equals 3 and minus 3, y is equal to 0, which I want. Anywhere from this way, if you pick anywhere a value of x now here, you're reading off a value of y less than or equal to 0. So therefore x is bigger than or equal to minus 3, so you're moving that way. And obviously this way for the graph to read off a value of x there. So you're reading off the values of, picking off values of x there where y is less than 0, which is what you want there. X is going to be less than 3. And what we've got now is the answers not disjoint, not split up, but they're all together, what I call a sandwich inequality altogether. So I can write that as 1. X is bigger than or equal to minus 3, that means I'm moving that way, and you stop at this point, x is less than or equal to 3. And there are your solutions to that. To follow very quickly on that, there's 2 examples. One thing I picked up from the students I was teaching, I can't remember the exact question was, but we had a question, I'm not actually going through this, but somebody, because it was written as a fraction, I think had something like that. Okay? Now, obviously you need to get that as a function of x. Some people took the quarter off and wrote it like that. Okay? Alright, that's one way of looking at it to get started. Or the other way around that is to get x squared greater than a quarter times both sides by 4, and you've got 4x squared bigger than 1, which if you take the 1 off both sides, you get 4x squared minus 1 is greater than 0, which is obviously implying y is greater than 0, okay? I'm not actually going to go through all that there. And now you should spot again. If you go from here, you should spot that as the difference of 2 squared, because 4x squared minus 1, factorising here, is 2x all squared minus 1 all squared. So I can rewrite that as 2x plus 1, 2x minus 1, set it equal to 0, and you'll get your 2 critical values, which is x plus or minus a half on that. And to just wrap up the first exercise of quadratic inequalities, these are the questions I will definitely want you to do on that. I'll just rip this off here so you've got down the board just to show you the questions that I've finished on this first part of the session on quadratic inequalities. And then going to the textbook, which you've got all term loaded onto your laptops at home, it's exercise 1. Okay, it's section, rather than give you the page number, it's section 13.2. Okay, so you'll be able to get to it because the page numbers are slightly different to term. And the question I'd like you to have done or go through is 2a up to a to d, so 2a to d, 3ab, ab, f and h, and then do question number 4. Okay, that's the first part of quadratic inequalities. The graphs get more complex, the process gets more complex, but the principle's the same, and it involves a lot of testing a lot of maths, factorising, sketching graphs, roots, x-intercepts and all that stuff. Okay, thank you very much.